So today we are going to take a lecture on paper solution of first and second semester summer 2014 of the subject engineering physics. I am Hardik and Maru from Engineering College, Junagadh. My name is Hardik M. Maru, designation Assistant Professor given by Engineering College, Junagadh. Let us move towards the first question of the paper solution. These are the paper solutions through which you can solve your paper if there is any question related to it. So let us move towards our first question of paper solution. The first question for paper solution is reduce Clausius-Mosotty equation with respect to its significance. Now, in this equation, you can see that the polarization for a single atom is given. Here, in this equation, P represents the polarization, N represents number of atoms per unit volume, alpha T represents total polarizability, whereas E internal represents the internal field. Now, P represents the polarization of a single atom with respect to total polarizability. So, this is the equation through which we are going to prove the Clausius-Mosotty equation. We know that alpha T represents total polarizability, which is equal to alpha E, alpha I plus alpha 0, where alpha E, alpha I plus alpha 0 is electronic polarizability, ionic polarizability and alpha 0, and the summation of all the polarizability gives you the total polarizability. Let us move towards next slide. For a cubic structure element, there are no ions and permanent dipoles. So alpha I and alpha 0, that is the ionic polarizability, are not present, so they are represented as 0. So according to the total equation, if we represent the second equation, that is polarizability, P is equal to N, the equation will become alpha E, because alpha I and alpha 0 is equal to 0. So instead of total polarizability, alpha E is represented instead of alpha T, because alpha T is equal to alpha E. Let us move towards first slide. Here in this equation, alpha I and alpha 0 is equal to 0, because in cubic structure alpha I and alpha 0 is considered as 0. So total polarizability is equal to electronic polarizability. So substituting these values in equation of internal field, we know that P is equal to N alpha E internal, and instead of that you can substitute the value of E plus P upon epsilon 0, which is the value of E internal. We have substituted the equation of E internal in this equation. So we get a new equation of polarizability. P is equal to N alpha E into bracket E plus P upon epsilon 0. Here E represents the field. Let us move towards the next slide. We also know that polarizability is also represented with relative permeability. So polarizability is equal to epsilon 0 E into bracket epsilon R minus 1. Here epsilon R represents relative permittivity. If we substitute this equation in above equation, we get another one, that is an alpha multiplied by E plus P upon epsilon 0. Here this equation of right hand side is instead of P. So in our previous slide you can see here the whole equation n alpha E and E internal. So instead of this n alpha E, E plus P upon epsilon 0, and on the other side P, we are keeping another equation, that is P is equal to epsilon 0 E ER minus 1, that is relative permittivity. Now moving towards the next point, here instead of P we have substituted the equation epsilon 0 E into epsilon R minus 1. So from this equation what we can get, that in this equation, in this term, E are common. So taking the E common from that equation, from this term we get a new equation, that is n alpha E 1 plus epsilon 0 upon 3 epsilon 0 into epsilon R minus epsilon 1, epsilon R minus 1 is equal to epsilon 0 E epsilon R minus 1. So from this equation we can get another equation, that is n E. Here there will be n alpha E, there will be a mistake, n alpha E will be equal to epsilon 0 epsilon R minus 1 upon 3 epsilon 0 plus epsilon 0 into epsilon R minus 1. If we multiply this equation with epsilon R minus 1, we will get epsilon 0 epsilon R minus 1, and we can take out the epsilon common from this term. So we get a new equation here, 3 epsilon 0 square into epsilon R minus 1 upon epsilon 0 into bracket 3 plus epsilon R minus 1. Here in the denominator there is 3 epsilon 0 square is due to the above equation, where the denominator's denominator will come into numerator and it will become 3 epsilon 0 square. Now accordingly we can get an equation that here from this equation 3 minus 1 it will be represented as 2. So equation will become 3 epsilon 0 square into epsilon R minus 1 into epsilon 0 epsilon R plus 2, because there will be greater sign, so it will be epsilon R plus 2. Here in this equation what we can get, 1 from numerator and denominator, 1 epsilon 0 can be cancelled out. So our new equation will be, the new equation will be n alpha E, that is n is the number of atoms per unit volume, alpha E is the electronic polarizability, which is equal to 3 epsilon 0. As I said, accordingly there will be the cancellation of epsilon 0 from numerator and denominator, there will be a single epsilon 0 in the numerator. So 3 epsilon 0 into epsilon R minus 1 upon epsilon R plus 2. This equation n alpha E upon 3 epsilon 0 will be equal to epsilon R minus epsilon 1 upon epsilon R plus epsilon 2. This equation represents with respect to relative permeability, and this equation represents the relation of microscopic and macroscopic elements of this dielectrics. So Clausius-Mossotti equation represents the electric field, the polarizability, which also represents the polarization with respect to the number of atoms per unit volume. So this was the question and its significance, through which you can prove and derive the equation of polarizability. Let us move towards the next question. The next question is actually a numerical which can be asked in 3 marks. This is the question which can be asked from dielectrics. This was the question from your last question paper. Calculate the polarizability and relative permittivity in hydrogen gas with a density of 9.8 into 10 raised to 26 atoms per meter cube. Given that is the radius of hydrogen atom, which is 0.5 angstrom. So, to calculate this, we have to calculate polarizability and relative permittivity. Here, in this equation, I will show you on a written board. It is a equation which can be represented on a written board. The equation is, let us represent alpha E is equal to 4 pi, that is epsilon 0 into r cube. So, we have the values of alpha E. Let me write it one more time. Alpha E is equal to 4 pi epsilon 0 r cube. If we substitute the value, of epsilon 0 r cube, it will be 4 pi, that is 3.14 multiplied by the value of epsilon 0 into r cube. The value of r cube is given, that is 0.5 angstrom. If we substitute this value, we will get the value of alpha E, which is your polarizability, or you can say it electronic polarizability. Now let us move towards the next point, that is relative permittivity. Let us move towards relative permittivity. The relative permittivity, that is alpha E, can also be calculated with respect to this. Alpha E will be equal to epsilon 0 into epsilon r minus 1 upon, it will be n, and n is the number of atoms per unit volume. Epsilon r is your relative permittivity. Now you want to find out this relative permittivity. So by substituting all the values of epsilon 0, n and alpha E, the value of alpha E which we calculated accordingly is 1.389 into 10 raised to minus 41, which will be equal to the value of epsilon 0 upon the value of n, that is 9.8 into 10 raised to 26, which will be multiplied by epsilon r minus epsilon 1. To take the equation as main epsilon r, you will get the relative permeability. So by taking the equation as epsilon r main, you can calculate the relative permeability. So let us move towards our slide. Here in this equation you can see that the equation is actually written as alpha E, which is equal to 4 pi into epsilon 0 r cube. The value of alpha E can be calculated by substituting the values of 4 pi, that is 3.14 epsilon 0 into r cube. The radius of hydrogen atom is already given, that is 0.5 angstrom. By substituting the value, you can calculate the first value. You can see in the screen, that is 1.389 into 10 raised to minus 41 farad meter square. That is the value of polarizability, or you can say electronic polarizability. You can see the second point, and the second point is the equation, that is alpha E is equal to epsilon 0 into epsilon r minus 1 upon n. We want to calculate the physical quantity which is in the bracket, that is epsilon r, and epsilon r is the relative permittivity. So, we want to calculate the relative permittivity, which is equal to 1.0015. By substituting the values of alpha E, epsilon 0 and n, we can get the values of relative permittivity. So, this is the main equation. Let me show you the equation again on this board. The equation to calculate alpha E is 4 pi epsilon 0 r cube. By substituting the values in this equation, you can calculate alpha E, which is electronic polarizability, and in the same manner, if you want to calculate epsilon r is your relative permittivity. So, to calculate epsilon r, we have another one equation, that is alpha E, which will be equal to epsilon 0 into epsilon r minus 1 upon n. So, by substituting the values of n, epsilon 0 and alpha E, we can calculate the relative permittivity by making the equation main of epsilon r. So, through this equation, you can not only calculate the polarizability